Okay? So the first thing I'm going to do is, based on the cast, I draw my little quadrants. And where are the arms going to be if the sign is positive?
1 and 2.
Okay? 1 and 2. So I have theta 1 and theta 2. And sometimes we'll move the solutions to names like x, but for now we'll stay with theta. Now I still have in there a little beta, even though for this one it's not significant, but that's my beta, and I also find the beta on the other side. So even without looking at the values there, I know for sure that I'll have a theta 1 that's equal to beta, and a theta 2 that's going to be equal to 180 minus the beta. Okay, so now I can go back and interpret the value here. So when is the sine of the angle root 3 over 2? For which of the special angles? Sorry?
45.
That would be root 2 over 2.
Sorry, 60.
60, that's right. Okay. And maybe after this example, look at a bit of a pattern so you can quickly remember them. So that means my first theta will be 60 degrees. My second one will be 180 minus 60. Yes. Okay, so if I name the steps here, I say step 1, you don't have to write this every time, but step 2, step 3, and this would be my step 4. Well, technically this is part of step 2, so I'll just write it in brackets still, technically step 2 and 3 together. And then step 4, what did I say I have to do? One last check. What was your step 4 saying? The domain, check the domain one more time and make sure that theta 1 and theta 2 is all that you need, right? And it is, because I'm stuck between 0 and 360. So that means I'm just going to say theta is, as a final answer, 60 and 120. Again, you don't have to label those steps, just remind yourselves to go through all these before declaring your final answer. Okay, so just before we move to the next example, I'll do a little chart here to help you out with remembering those sines and cosine values for special angles. So if I say I'm going to start at 0 degrees, the next one would be 30 degrees. You can do it on the back of the page if you want at the bottom, because you might want to write a few other examples just at the bottom of the second page. 45 degrees. So if I say I'm going to start at 0 degrees, the next one would be 30 degrees. You can do it on the back of the page if you want at the bottom, because you might want to write a few other examples just at the bottom of the second page. 45 degrees, 60, 90, and we can keep going, but the other ones will repeat. So I'm just interested in remember these ones. So we just worked with sine of 60. Sine of 60 was root 3 over 2. Root 2 over 2 is for 45. And for 30, we have 1 over 2. So does anybody notice a bit of a pattern that you can use quickly to remember them? Does the numerator increase or decrease as we go towards a larger angle? It increases. And I can even think of 1 over 2 as root 1 over 2, right? So there's that pattern, root 1, root 2, root 3, over 2. Sine of 0, again, you'll remember this in time, but we said each point has what coordinates? What is x, what is y? In the coordinate plane, which is x and which is y, sine, cos. X is cosine, that's right. So that means for sine of 0, I'm over here. The point is 1, 0. So what is the sine value at 0 degrees? This is the sine value, so yes, I have a 0. And if I go at the top for 90, my point is 0, 1. So in that case, the sine is 1. Okay. Now what do you think happens for cosine of theta? If you notice the coordinates here, so at 0 degrees, I'm starting with 1 for cosine, and at 90 degrees, I'll have 0 for cosine. I'm going to start with those. I have a 0 over here and a 1 for 0 degrees. And what do you think happens in between? We talked about the unit circle last time, and you could have noticed a bit of a pattern. Yes, Nicholas?
It just decreases that then.
Okay. So we travel the other way, right? A root 3 over 2 here. The root 2 over 2 stays because we know for 45 sine and cosine are equal. And we have 1 over 2. So these two are just, you relate them back to those triangles that we drew. Those come from the 30-60 triangle. So that's why the sine and the cosine are inverted. So next time you think of this, just quickly, you don't only have to remember the sine having an increasing pattern, and then you just match up the cosine, right, for each angle. Just to make things a little faster. But I know you all know the unit circle, right? So it all comes from there in the special triangles. Now the second equation has root 2 sine of theta plus 1 is equal to 0. And we notice the domain changes slightly. So I go from negative 90 degrees to 270. So the first step I need to take here is algebraic, right? I want to isolate for this sine of theta. It's not explicitly given to me. So I'll just say algebraically modify the given expression. And this will happen more often than be given the type of equation we did before. Okay? So you usually have to do this step first, maybe 1 or 2 or even 3. We'll see another example in a bit. So what would you suggest? How would I modify that to isolate for just sine of theta? Minus 1 first? Yep, that's right. So root 2 times sine of theta is equal to negative 1. And what would happen next? Not quite done yet. There's a multiplication there. Well, if I had root 2 times x is equal to negative 1, how would I isolate for x? So you have to treat the sine of t, right? Yeah, divide by root 2, right? So both sides, if you divide by root 2, you get negative 1 over root 2. Okay, just remind, in brackets, you don't have to write this down, but if you had root 2 times x is equal to negative 1, you solve for x by just dividing by root 2. So sine of theta is just another number, right? A value. So you can treat it all together. Don't think of sine and theta as separate. Okay, so now what do I do next? The cast, yeah. So because sine is negative, which quadrants am I going to be in? 3, yep, and 4. So sine negative would be here and here. And we have 1, and we have the second one. So a theta 1 and a theta 2. There might be more than that, so I'm just going to indicate the beta here on both sides. Okay, so let's go to work. What's next? I have my cast in place. I know which quadrants it's going to fall in. What do I do with this? I've treated the negative aspect of the ratio. What else am I going to do next? What did we do with the previous one? I can think back of the beta, right? So for the beta, the equation is just sine of beta is positive 1 over root 2. That's right. So beta here is equal to 30 degrees. Oh, and I didn't write down theta 1 and theta 2. Oh, 45, yeah. Yeah, and I'm also thinking something else. 1 second, I'm just going to move. Yep, so it's 45, not 30. And for theta 1, we have 180 plus the beta. For theta 2, I have 360 minus beta. Olivia, do you have a question? Okay, so for beta is 45. That means now I can write out my theta 1 and my theta 2. So 225 and theta 2 is 360 minus 45. That's 315. So I have the two values. Yeah.
Shouldn't it be minus 45 because of the
Okay, we're not done yet. So we're going, if you're talking about the domain, right?
Yeah.
So the last check here, after you have all your values for 0 to 360, you're going to go back and check the domain. When we said to cover the entire domain, we plus and minus these values, right? Just to do it systematically. So to cover all the way to 270, I'm going to add 360. Okay? So for each one here, I'm going to go 225 plus 360, and I'm going to go 315 plus 360. And then I'm going to check to see if it's within the actual domain. And I'm also going to subtract 360 to make sure I cover the bit before the 0. So 315 minus 360. And we can work out the values. We don't really have to. Technically, you could just say, so 225 minus 360 is 135. And 675. And this one would be negative 45. Okay, so from these values, which ones match the domain of negative 90 to 270? Yes? Yes, Olivia?
350 minus 45.
Yeah. So what did you say, 350?
315.
Yeah, but that's one of the original ones. So these will always work, the first two that I get. This one doesn't, yep, this one doesn't, and this one does. Okay, so my theta is going to be in order negative 45, 225, and 315. Sorry? Oh, is it not? Right, it's outside. So this one, and two solutions. Yep.
How do we do the plus 360 minus 360? What was that?
Which one?
The 225 plus 360.
Well, you want all the terminal arms, right? So if you find the original two terminal arms, the other ones would have to be on the same terminal arm. So I just have to add a full circle or subtract a full circle.
Right.
So the original graph that we had at the top, this one here, so I'll have, let's say blue or orange, this one, that's one solution, right? But I can go around the circle and end up on the same terminal arm, and that's a different angle. So whatever solutions I get have to be placed on those two arms. So that's why I add or subtract. Okay? Now you don't have to show all of this if you want to do it in your head. Sometimes it's dangerous, but you can. Okay? I just showed everything so you know where it comes from and how you select it, but you could just go quickly in your mind through the beta, adding or subtracting that too. Okay, for 3. So the domain here goes from 0 degrees to 720. So how many times do I go around the circle? Twice, okay. Girls, do you have a question? What's the question?
Why do you need to add and subtract 300?
Well, just to make sure that once you go around the circle once, backwards and forwards, you're capturing all the solutions that you need. You don't have to show all that work. If you want to go through the beta, you can do the algebra too that way. But if you, the reason why the domain is given from negative 90, right? Oh, actually, we don't have to add 360. We just have to subtract. I don't know why I added, right? Because I'm going from negative 90. So whenever I pass the 0 and 360, I'm going to subtract for going past 0 to the left of 0. Subtract 360 because I'm covering the next circle over, going backwards. Okay? If I'm passing 360, then I'm going forwards. So this here, I did extra work. So the 360 plus doesn't really belong because I'm stopping at 270. So that's extra work. Okay? Wasn't paying attention. So you only have to check going backwards through the circle once. Okay. Can we move on to tangent?
Yes.
Okay. So where is the tan Olivia, do I have to move you?
No.
Where is the tan negative? 1, 2, 3, yeah. So theta 1 and theta 2. I have my little beta. And theta 1 would be subtracted from 180. And theta 2 subtracted from 360. For an actual value, what is beta? When is the tan 1? So tan of beta is 1. 45 degrees, again, we have beta is equal to 45. So that gives us a theta 1 of 180 minus 45, which is 135, and the theta 2, 360 minus 45. Okay, so this is one circle, counterclockwise. Okay, so we're going to add plus 360 and 315 plus 360. So I'm getting 495 and 675. And one last check that it all fits. 135 is in the domain, 495 is, 675, and 315. So the theta is in order. We have 135, Do you guys want to give 4 a shot before I cover it? Okay, I'll give you a few minutes. Remember, the algebra is the first step. Oh, that should be sine of theta, not sine of x, the second term. So just correct that, sine of theta. And the domain is the typical 0 to 360. Oh, this one? Sine squared of theta is just sine of theta all squared. Right? But it's so that we don't confuse the theta being squared, we put the square with the sine. But it's just the sine, the whole number, all squared. Okay? So you can write it in brackets and then put the square outside. So what does that look like? Does it remind you of any type of equation you've seen before? I hear whispers, but I can't hear properly.
Okay.
It looks like a quadratic. And many of these will be factorable, just because nobody's trying to torture you with a quadratic formula in trigonometry. So one thing you could do right away is just tell yourself that sine of theta is equal to x, and rewrite it as 2x squared plus x minus 6. You don't have to. You can still work with the sign. There's nothing wrong with it. Okay? But if you change notation, it might be a bit quicker. Do you remember how to factor quadratics? Okay. What terms do I look at? 2 and negative 6. That gives me negative 12. And what factors? So I have 1, 12, 2, 6, and 3, 4. Which ones do I need to sum up to 1? Okay, yep. So that gives me a 2x squared plus 4x minus 3x. So 2 factors out. I have an x plus 2 and an x plus 2. Okay, now I'm done with the algebra, and I can go back to the notation in terms of sine and cosine. Okay, so I minimize that. Like I said, you can keep it in 2 sine of theta minus 3, and then in the other one I have sine of theta plus 2. Okay, and how did we solve quadratics? We just go for each solution in each bracket, right? The first bracket could be 0, the second bracket could be 0, so the first one will give me 2 sine of theta minus 3 is equal to 0. The second one, I'll get sine of theta is equal to, well, okay, plus 2. Sorry? No, it's plus. Okay. So I get those two equations out. I'm just going to solve each one individually, okay? Just like what we did before. So this one will give me sine of theta is equal to 3 over 2. That's not a very good one because we get no solution. That's okay. We'll do one more. And then this one, sine of theta is equal to negative 2. But if we remember the unit circle, you could go ahead and treat your positive and negative and cast. But before you do that, you can think of the maximum and minimum value for sine and cosine. What did we say they were? The unit circle had what radius? 1, right? So you can never go above 1 or below negative 1. Right? So if that's true, can I have any solutions here? No. This one's greater than 1. And the second one is less than negative 1. Okay? So that means the theta, there are no solutions here. And there should be some quadratics in there in your work where you do get solutions. So let's pick one. On the back of your page, we'll do one more quadratic where one of them, at least one, has solutions. Because you see here, if each of these were to have solutions, I would actually start with 4 basic ones, and then I would have to go and check my domain and maybe add or subtract. But the basic ones I would start with would be 4 if it were possible to have solutions. So quadratics, just pay attention when you cover these. Let's go with 10b on your workout sheet. So you can write it on the back. Just have an example of where there are solutions. Okay, so cos squared of theta plus cos of theta is 0. And even though it says their domain 0 to 360, we're going to look at 0 to 720, just to show the abundance of solutions that comes out of quadratics. And I'll do this one without changing notation. I'm not going to go to x and y, just so you see that it is possible to keep it that way. I'm going to factor out a cos of theta, and cos of theta plus 1 is what's left behind. So the first term automatically gives me one of the solutions. Cos of theta is 0. The second one, cos of theta is equal to negative 1, or I'll write it as a sum first.
How did you get the second line?
Sorry?
Second line of working?
So you factor out the cos theta. So if you have x squared and you divide by x, you're left with an x behind. Okay. So think, this cos squared of theta is just cos theta, all squared. Okay. So all of these, this one stays as it is. This one is cos of theta is negative 1. Do we remember when cos of theta is 0, or should we draw our unit circle? Okay, so remember the extreme points is what you use for 0, 1, and negative 1. So this point is 1, 0. This is negative 1, 0. And the cosine is represented by which of them? The x or the y? The x, okay. So this is cosine, one of the ones I'm interested in. But where's the 0? I don't have the 0 on either of these. What points could I draw to show cosine is 0? On the y-axis, we go top and bottom. Let's see, this one is 0, 1, and this one is 0, negative 1. So where's the cosine 0? It looks like here, that's a cosine, and here, that's also a cosine. Okay, so the very first equation will give me theta is equal to 90 degrees, and what else? 270. And the third one will give me what? Sorry? Well, I'm starting the values given, right, in the equation, so I only have 0 and negative 1. At this point, the cosine is 1, not negative 1. Okay? So what's the third angle?
450.
Did you say 450?
No, yes.
180, right, for negative 1? It's this one here. Okay, so we have 3, and we said now, because we're covering all the way into 720, I'm going to add 360 to each of those. Okay? So let's see, 90 plus 360, 270 plus 360, and 180 plus 360. Okay, do they all fit within 0 to 720? 90 does, 270 does, 180 does, 450, 630, 540. We're good? Okay. So I have how many solutions here? 6 solutions. Okay, so for now, for homework, you only have 7 through 11. Leave 12 for now, but we'll go back in 13 and 14. But as usual, don't do all of them, so don't do 7, A to F. Just do one of each, and then go back and do a few more. Okay. Overall, this is pretty straightforward, right? It's just going backwards from what we did before. And the best part is doing quadratics again, right? It's all connected.